Alright, in this video we are going to talk about how we can use Dropout in PyTorch. So in the previous videos we discussed that Dropout is a technique that randomly drops hidden layer units during training. And we mentioned that during inference we want deterministic behavior. So during inference we're not dropping any nodes. Now the question is, how can we accomplish that in PyTorch? Well, there's of course also a Dropout class in PyTorch to make that very convenient. So all we have to do is to place the Dropout class just after the activation function. And then inside the Dropout class we can define the drop probability. For example here 0.2 and 0.5. And the drop probability itself is yet just another hyperparameter that we can tune. So when we add these dropout layers then, PyTorch will automatically randomly drop the nodes during training. But how do we then get this deterministic behavior during inference? For that we can then also use model.eval to put the model into evaluation mode. This is yet another reason why it's important during inference to always put the model into evaluation mode. Otherwise, if we forget that, the network will randomly drop nodes during the real-world prediction, and this will then yield unpredictable results. So here I ran an experiment where I trained a network without dropout and with dropout. And you can see here on the left-hand side that we have a network that has a high degree of overfitting. When I add dropout to it, we can see that the gap between the validation and the training accuracy is much smaller. So using dropout, here we are reducing the degree of overfitting. However, you may also notice that the overall validation set performance is decreased compared to the variant where we are not using dropout. So using too much dropout can of course reduce overfitting, but it may also harm the overall performance of the network. So when you're using dropout, it's always a good idea to tune the dropout probability and compare it to the baseline without dropout. And as I mentioned earlier, if you want to have both a low degree of overfitting and a good overall performance, it's never a bad idea to collect additional training data. Alright, so now that we talked about different tips and tricks to tune our network and to reduce overfitting, let's talk about how we can debug our neural networks in case we have unexpected behavior or little bugs in our code.